Okay, so this work is like similar to the past two ones. This came from like a little chat I had with Ana Catalina, where we say, well, she's like great psychology. I know a little about neural networks, so what can we do to get those things together? We came with this project just a couple of months ago, so we're just proposing this as a future, like, real project. So, what do we do? Let me explain the problem. So, in normal aging, there's a gradual detriment in the cognitive functions, usually in the learning memory. But sometimes this normal aging can like derive in some cognitive impairment which involves the loss of attention, memory, language, or executive functions. This can also then transition to a state called dementia. Dementia is just a cognitive impairment which also involves problems with daily tasks like eating or getting dressed, something that really it's some problems for the normal life. And it's not like, for example, the muscle or the joints are damaged or maybe the reflexes are compromised. It's just that the brain doesn't know anymore how to do these simple tasks that we learn when we're child. So identifying this like transition of this state in elderly people is very important, both for patients and caregivers, as it may allow early treatment that can delay or even prevent the illness process. So, how can we like analyze this? I present two different tests that are currently done by neuropsychologists, where they ask people to draw these kind of figures. The clock drawing test is, as in the clock drawing test, the psychologist and neuropsychologist ask the patient to draw the face of a clock with all the numbers and the hands pointing at 10 past 11. This all by memory, so they don't show like an example of the picture. There's another test that is the ray austeric complex figure, where they ask the patient to replicate the figure. These two tests have shown different like they test different specific areas of the brain. For example, in the clock test, errors such as inaccurate time settings, missing hands or numbers, and number substitution or repetition provides useful information for dementia screening, while in the ray complex figure involves a more wide network of brain areas, and that is why it has shown high sensitivity for detecting brain damage, specific brain damage. So what is currently being done with this? There has been an attempt to join this test by neuropsychologists, where they ask the patient to do the drawing and then they score it with a numerical score. Then they join that with the historical clinical data and put that all in a neural network to predict dementia or the cognitive state of the patient. But what we're proposing is just to skip that step and use an end-to-end neural network that can, well, you can see this, but that takes as input the drawing, and it analyzes the pattern and the styles of this drawing to predict if we are like in a normal aging state or maybe we're going down to a dementia or cognitive impairment state. It's really difficult to see the images, but this is for a normal like aging person. The second one shows like a mild cognitive impairment person, and the last one is a real person with dementia. And the drawing is really like, they have a lot of information that we could study there. As Anna said, we're only in getting the data and finding maybe some collaboration to get this done. But yeah, let's hope that this Congress helps us do that. Thank you.